Let's take a look at this example. What we're supposed to do first. I would combine these two voltages together, okay? Please notice that we have positive terminal of my voltage source 2 is connected to the negative terminal of my voltage source 1. So it means we have to add these two voltages together. So my total voltage V total is equal voltage source 1 plus voltage source 2. So I have 9 volts plus 9 volts is equal 18 volts. Okay, so V total is equal 18 volts. Next, please notice that these three resistors, these three are in parallel. Okay, they are connected together at the top. They are connected together at the bottom. Okay, so these three resistors are in parallel. That's why I'm going to write that R1, 2, 3 is equal, I'm going to use the formula 1 over R1 plus 1 over R2 plus 1 over R3. So my R1, 2, 3 is equal 1 divided by, open parenthesis, 1 divided by 6K plus 1 divided by 10K plus 1 divided by 12K. So if R1, 2, 3 is equal 1 divided by, open parenthesis, 1 divided by 6 exponent 3 plus 1 divided by 10 exponent 3 plus 1 divided by 12 exponent 3. Close parenthesis, this is equal 2.85 kilo ohms. Okay, so this is the total resistance for these three resistors. I can say equivalent resistance for these three resistors together. Next, please notice that these two resistors also are in parallel. Okay, they are parallel. Okay, these resistors over here. So I'm going to use, because I have just two resistors, I'm going to use the formula called product over the sum. So if R4, 5 is equal R4 times R5 over R4 plus R5. This is equal, R4 is equal 20K times 40K over 20K plus 40K. This is equal 20 exponent 3 times 40 exponent 3 equals, divided by, open parenthesis, 20 exponent 3 plus 40 exponent 3. This is equal 13.33 kilo ohms. 13.33 kilo ohms. Okay, so this is the equivalent resistance for these two resistors. Next, we can redraw the circuit. Okay, so we have total voltage, call this V total. Total means the voltage sources combined together. Okay, so we have, next we have resistor over here, and this is resistor R1, 2, 3, and we have another resistor over here, R4, 5, and I have resistor over here, R6. Okay, so please notice that at this time these two resistors are in series. So I can simply add them up. So R4, 5, 6 is equal R4, 5 plus R6, where R4, 5 we found is equal 13.33K plus R6, which is equal 15K. So R4, 5, 6 is equal 13 plus 15 is 28.33K. 28.33 kilo ohms. Okay, so these two resistors together have this resistance. Okay, again I can redraw the circuit to make this picture more clear. Okay, this is my resistor R1, 2, 3, and this is my resistor R4, 5, 6. Now we can see that these two resistors are in parallel, so I can find the total resistance using the product over the sum. So if R1, 2, 3 times R4, 5, 6 over R1, 2, 3 plus R4, 5, 6. This is equal R1, 2, 3 we found is equal 2.85. 2.85K. Okay, times R456 is equal 28.33K over 2.85K plus 28.33K. So I have R total is equal 2.85 exponent 3 times 28.33 exponent 3 equals, divide by open parenthesis, 2.85 exponent 3 plus 28.33 exponent 3 close parenthesis equals 2.58K. This is 2.58 kilo ohms. Okay, so this is my total resistance. And if you want to redraw the circuit, your circuit is going to look like this. I have voltage source, and this is my total resistance. Okay, so this is equivalent circuit to the big one. Okay, so it means that this circuit can replace this one. Next, we're supposed to find the total current. Okay, I have to find the total current, I total. In order to find I total, I simply use Ohm's law. I total is equal voltage total over R total, where voltage total is equal 18 volts over R total, which is equal 2.58K. Okay, so this is equal 18 divided by 2.58 exponent 3. This is equal 6.97 milliamps. This is my I total. Next, I'm supposed to find the current which goes through resistor R3. I'm supposed to find I3. By the way, I found I total already. So I3. Please notice that the resistor R3 R tray is connected across the voltage source, okay? Because this connection goes directly to this resistor and goes to ground, right? So I can say that my V tray is also equal to V2 is equal to V1, and this is also equal to V total. So I have V tray is equal to V2 is equal to V1, and this is equal to V total, and this is equal 18 volts. So if I want to find I tray, let me write this down over here. I tray is equal V tray over R tray. So V tray we found is equal 18 volts divided by R tray, which is equal 12 kilo ohms. And this is equal 18 divided by 12 exponent 3. This is equal 1.5 milliamps. Okay, so this is equal 1.5 milliamps. This is my I3. Okay, so we found I3. Next, we're supposed to find the current which goes through the resistor 5. Okay, we're supposed to find this current. So in order to do so, I'm going to find first the current which goes through this resistor. Why? Because this resistor represents these three resistors together. Okay, so it's going to be much easier for me to find the current through this resistor first. So I'm going to find I 4, 5, 6, and please notice that this current, okay, this is going to be my current I 4, 5, 6. This current is going to split into two currents. This is going to be current I4, I5, okay, and after that is going to get back together and is going to also create I6. That's why I'm going to say that this current is also equal to I6. So we simply perform the calculations and we write nothing else, just Ohm's law. So this is V total over R4, 5, 6. Okay, so this is V total over R4, 5, 6. V total is equal 18 volts over R4, 5, 6. R4, 5, 6 we found is equal 28.33 kilo ohms. 28.33 kilo ohms. And this is equal 18 divided by 28.33 exponent 3. This is equal 635.36 microamps. Okay, so this is the current which goes through this resistor. This is the current which will go through this part of the circuit and will go through the resistor R6. Okay, so, and the problem is asking me to find I6, so we can say that we found I6. Next, we're supposed to find the current which goes through resistor R5, because these two resistors are in parallel. Okay, and I know the current which goes through this part of the circuit. I can use the current divider rule. Okay, so I'm going to simply write that I5 is equal I4 4, 5, 6, this is the total current which goes through this part of the circuit, times total resistance, I mean equivalent resistance of these two resistors, so R 4, 5 over R5. I 4, 5, 6, we've found this is equal 635 635.36 microamps times R45. R45 is equal 13.33 kiloohms. 13.33 kiloohms over R5, which is equal 40 kiloohms. This is equal 635.36 exponent 6 negative times 13.33 exponent 3 divided by 40 exponent 3, close parenthesis, equals 211.73 microamps. Okay, so this is the current which will flow through the resistor R5. So this is my I5. Next, I'm supposed to find V2. V2 is the voltage across resistor R2. Okay, and we said that V2 is equal 18 volts. So you can say that we found V2. Next, we're supposed to find V6. V6 is the voltage across resistor R6. Because I found the current already which goes through the resistor R6, okay, this is my I6, and I know the resistance, I can find very easy V6. V6 is equal I6 times R6. This is equal I6 is equal 635.36 microamps times R6, which is equal 15 kiloohms. Okay, so we have 635.36 exponent 6 negative times 15 exponent 3. This is equal 9.53 volts. 9.53 volts, and this is the voltage across resistor R6. It's my V6. Next, I'm supposed to find the total power. Total power. P total is equal V total times I total. V total is equal 18 volts times I total, which is equal 6.97 milliamps. This is equal 18 times 6.97 exponent 3 negative. This is equal 125.46 milliwatts. 125.46 milliwatts. Okay, so this is my total power, and we're supposed to find also power at resistor R4. Okay, in order to find the power at resistor R4, what I'm going to do, I'm going to find current which goes through resistor R4. I4 is equal I4, 5, 6, or we can simply say I6 minus I5. Okay, we found I5. We have I4, 5, 6. Okay, so what I'm going to do simply, I'm going to, from this current, subtract this current, and I'm going to get this current. So I have, this is my KCL, I4, 5, 6, and we found this is equal 635.36 microamps minus I5, which is equal 211.73 microamps. This is equal, we have 635.36 exponent 6 negative minus 211.73 exponent 6 negative equals 423.63 microamps. Okay, so this is the current which goes through the resistor R4. Now, if you want to find the power at this resistor, you're supposed to simply, let me just find some space for it, power at resistor 4, P4 is equal I4 to the second power times R4. And this is equal 423.63 microamps raised to the second power times R4. R4 is equal 20K. And this is equal, we have 423.63 exponent 6 negative to the second power times 20 exponent 3. This is equal 3.58 milliwatts. 3.58 milliwatts. So now we found P4, so now we can say that problem is solved.